Today, I have the pleasure to introduce the first of a series of IKHAPP thematic discussions on agricultural plastic. And today's will have a focus on the Global South and the Asian context. Increasingly, plastic is becoming an important commodity in agricultural production, with an expected expansion in use, including in countries of the Global South. The concern about the environmental and agricultural implication of plastic pollution has been assimilated by the international policy agenda, and in this phase in which the world society comes together to negotiate for a global plastic treaty. Addressing the issue of agricultural plastic requires sharing information, concerns and perspective among scientists, farmers, industry representatives, waste managers, and food system operators in general. The scientific community and the Food and Agricultural Organization of the United Nations are committed to collecting and analyzing this perspective and transferring them into policy making. Today's webinar introduces and launches an electronic survey that enables such an interaction. We will hear more about this survey later today. Some housekeeping information. We have now a series of 6 very interesting presentations. I invite all the speakers to closely adhere to their time slot and to keep their microphone muted when they are not presenting. At the end of the series of presentations, we will have a 10 minutes quality and answer section. And I invite all the people in the audience to write their question in the chat, indicating who among the speakers the question will be addressed to. I am now pleased to present a list of 6 excellent speakers and panelists. First of all, I'm delighted to introduce Dr. Richard Thompson. Richard Thompson is an agricultural plastic and sustainability specialist at the Office of Climate Change, Biodiversity and Environment of the Food and Agricultural Organization of the United Nations, FAO. Richard Thompson joined FAO in 2003 following a career in international hazardous waste management. He has co-authored FAO's first global assessment of plastic use in agriculture. He's also part of the team developing FAO's voluntary code of conduct on sustainable use of plastic in agriculture. Thank you very much. Richard, please, the microphone is yours.
Thank you, Luca. So, plasticulture has become a well-used term amongst agriculturalists. From mulching films, plant support twines, greenhouse films, silage films, tree guards, to fishing nets and traps. Plastic products are used in virtually every sector of agricultural production. They undoubtedly deliver benefits in the short term, but the world has only recently become aware of their inappropriate use, and mismanagement causes longer-term harm to human health and the environment. This led FAO's governing body, the FAO Council, at its 171st session in December 2022, to ask the organization to do 3 things. Firstly, to support the negotiations of the international legally binding instrument on plastic pollution, specifically on issues related to plastics used in agriculture. Secondly, to develop a new voluntary code of conduct on sustainable use of plastics in agriculture. Just as an aside, voluntary codes of conduct have been particularly effective in helping countries to develop their sector-specific legislation. For example, the International Code of Conduct on Pesticide Management is the main plank of how countries develop their legislation on pesticide registration and pesticide use. And the third thing that FAO's Council asked the organization to do, and most importantly, and the reason that we're here today, is to support the efforts of the Code of Conduct and the International Legally Binding Treaty by undertaking further scientific and evidence-based assessments related to the distribution, benefits, trade-offs, and risks of plastics for agricultural use, and their alternatives. in order to address knowledge gaps on plastics in agriculture and taking into account members' past and ongoing efforts, as well as developing countries' needs and challenges. FAO is pleased that the International Knowledge Hub Against Plastic Pollution is organizing this webinar to explore the state of knowledge about plastics used in agriculture and their alternatives, and to identify critical areas for further investigation. This information will be vital for policymakers to make their decisions, aiming to improve agricultural production across all dimensions of sustainability, environmental, but also social and economic, and in efforts to achieve food security, food safety, and nutrition. I cannot overstress the importance of your efforts to fill these knowledge gaps and wish you all an insightful and successful discussion today. Thank you.
Thank you very much, Richard. Thank you very much for this very important introductory note. I move now on to our next speaker, Dr. Girija Bharat. Girija Bharat, she is founder and director of Mugama Consultants, India. She has more than 30 years of experience in research and consultancy on the environment and natural resource management. She has a PhD in chemistry and has authored a number of research and technical papers related to various aspects of natural resource management. Her area of expertise includes water quality, emerging contaminants, water resource management, and plastic waste management. She has contributed to several national and sub-national policies in India. She has been the principal investigator of India-Norway cooperation project on capacity building for reducing plastic pollution and chemical pollution. Girija is also a key component of the IKHAPP, this knowledge platform organizing this event today, and I'm very pleased that she agreed in providing some background information on this platform before we move on with the topic of today. Thank you very much, Girija.
Thank you so much, Luca, for the kind introduction, and good morning to colleagues from European countries, and good afternoon to everyone else from India. Thanks for being part of this webinar today. We, the IKHAPP team, comprising of scientists and professionals from Norwegian Institute for Water Research, Mugama, Grid Arendal, SALT, we are jointly organizing this knowledge hub and organizing a series of international conferences, webinars, to generate scientific publications. This is funded by the Research Council of Norway. And we are glad to have the Food and Agriculture Organization, the premier organization of the United Nations, to be on our panel today to discuss the very important aspects of plastic pollution caused by agriculture plastic. This is a topic of great importance because plastic has been and is being used in agriculture for several big years. I will not be wrong if I say decades, because of its various uses like drip irrigation, sprinkler irrigation, subsurface drainage, canal lining, pond lining, greenhouse, and several others. Plastic can play, we also call it plastic culture because agriculture, plastic in agriculture, which can play an important role in facilitating judicious usage of water. And it is estimated that appropriate application of micro irrigation technologies can result in water saving up to 50 to 70%. And the resulting improvement in net farm income is substantial. However, it comes with a huge price, and we are all aware of it, because unsustainable plastic waste has complex implications for the development and resilience of communities in the impacted areas, particularly the coastal areas, developing countries with large populations and transitional economies. And plastic pollution is one of the most important global challenges, which negatively impacts biodiversity, the quality of life, and human health. And at some time, plastic waste is at the base of the economy of millions of people in Asia, because people at the bottom of the pyramid are involved in a huge way. The informal sector in plastic waste management, most of them are often marginalized, and they represent a key role and in reducing plastic pollution. The International Knowledge Hub Against Plastic Pollution, IKHAPP, its mission is to collect, critically analyze, and disseminate scientific knowledge to support effective policies and actions to fight plastic pollution globally. We have the Scientific Coalition for an Effective Plastic Treaty, and community of scientists are here today. I'm glad for that. Well, we don't have actually a solution yet, because we are not sure how big a harm it is causing, how big a benefit it is causing, etc. The numbers are there, but still it is still under debate and discussions. And we provide knowledge through various aspects of dissemination activities. And I'm sure today's webinar will help unravel many of these mysteries and provide a lot of knowledge for going forward. Having said that, I would also like to mention that this scientific coalition of IKHAPP we are independent. We follow the principles of sustainable development, and we link local as well as global issues for creating concise and accessible information from complex and dispersed knowledge bases without oversimplification. It is very relevant to several of the sustainable development goals: SDG 1, that is no poverty; SDG 3, that's good health; SDG 6, water and sanitation; SDG 8, that is decent work and economic growth; SDG 9, industry and innovation; SDG 11 is sustainable cities; SDG 12, that is sustainable consumption and production; and SDG 14, which is life below water. So it impacts actually several of the sustainable development goals. And through this webinar, we are trying to specifically aim at contributing, as Richard just mentioned, to contributing to the international governance efforts led by FAO, Food and Agriculture Organization, towards formulating the code of conduct. We also aim to provide background information for framing effective provisions on agriculture plastic under the upcoming Global Plastic Treaty. And the overall aim is to equip the society with series of screened by science information, tools, roadmaps that can help achieve verifiable, safe, and sustainable use of plastic in farming. Today, we will hear from expert speakers from India and European countries about the pros and cons of this agricultural plastics, and it will help in understanding the global good practices. With this, I give the floor to Luca again to take the proceedings of the day forward. Thank you, everyone, for being here. Good night. Thanks.
Thank you very much, Girija, for this introduction. I am now opening the series of thematic talk. The first one is provided by Lauren Weir. At the title, the talk will be titled "The International Development on the Use of Plastic in Agriculture." Before this, I'd like to say some biographic note. Lauren is an ocean campaign leader at the Environmental Investigation Agency, EIA. As an ocean campaign leader for this NGO, she's a passionate advocate for marine conservation and sustainability. With over 10 years of experience in environmental advocacy and policy, Lauren has developed a deep expertise in marine conservation and policy development, particularly in the areas of illegal fishing, overfishing, and habitat destruction. As a leader at the EIA Ocean Campaign, Lauren has spearheaded numerous initiatives aimed at fighting environmental crime, promoting sustainability, and strengthening international policies to protect the world's ocean and terrestrial environments, including from plastic pollution. Lauren is a graduate at the University of California, Santa Cruz, where she studied marine ecology and conservation biology. Lauren, please, the platform is yours. I think we have, we cannot hear you and we cannot see you. So,
Hello.
hello, now we can hear you,
Oh, wonderful. Thank you. Apologies. I'm just going to share my screen.
please.
Can everyone see my screen?
Yes, we can see it.
Wonderful. Thank you very much. And thank you very much for the invitation to present today. So as said, my name is Lauren Weir. I'm a senior campaigner at the Environmental Investigation Agency. We are an NGO based in London that investigate and campaign against environmental crime and abuse. So today I will be touching on the international developments on the use of plastics in agriculture, with a particular focus on agroplastics in the UK supply chain. This stems from our work and production of a 4-part report series on the issue entitled Cultivating Plastic. Of course, every region and every country has particular needs, obstacles, and situations when it comes to addressing the issues of agroplastic use and waste. I do, however, hope that the findings I present provide insight into 2 particular facets of the conversation. Firstly, the interconnectedness of global supply chains and how the environmental and human health harm that stems from agroplastic use is present globally, and thus how necessary a collective global response is, especially given food security challenges and climate change. And secondly, and linked to this, using our findings specifically with regards to the UK supply chain on how policy and market-based drivers not only form part of the knowledge gaps when it comes to agroplastics, but also form a cornerstone with regards to demands for safe and sustainable use and management of agroplastics. So understanding, of course, that every national context is different, I hope some of our findings that I'll be presenting today may prove to be a helpful case study in the conversations that will be had today, as well as those going forward. So as a first step, a very brief overview on the international developments on the use of plastics in agriculture. Agroplastic use proliferated since the 1950s, a period of increased production of single-use plastics and the development of modern-day intensive monoculture agriculture. As I am sure you're all very well aware, data surrounding global agroplastic usage is lacking. However, the FAO in 2021 provided an excellent global assessment of agroplastic use using best available evidence to date. They estimated that best available data shows that at least 12.5 million tons of plastics used globally in agricultural production annually, an amount equivalent to almost 3.5% of the global plastic production per annum in 2018, with a significant proportion of agroplastic use being attributed particularly to that of plastic films. Agroplastic use varies from region to region. It is also important to account for per capita use in this regard. What we wanted to highlight in our Cultivating Plastic report series, however, is that there are not only national level food production and food security drivers when it comes to agroplastic use, but also that of global supply chains. So when conducting an analysis on the UK food supply chain within our report series, we found the following. The extent of global impact and dependency on imports. For instance, in 2021, the UK had a self-sufficiency ratio of 60%, meaning it only produced 54% of the fresh vegetables and 16% of the fresh fruit it consumed in 2021, dependent on others to provide this. DEFRA states, which is the Department of Environment, Food and Rural Affairs in the UK, that UK food production is driven by market forces rather than aiming to maximize calorie production from available land. When it comes to major sourcing regions with regards to produce categories, there are some overlaps with the UK, namely Spain, France, and the Netherlands being key sourcing countries. But typically, different produce and food, which are all dependent on different types of agroplastic use and have different sourcing regions. And the result of that is that the impact of the UK food supply chain an agroplastic footprint is complex and fragmented. For instance, a significant amount of fruit imported from the UK is from South America, whilst many vegetables imported from other European countries. Of course, seasonality and year-round demand formed a particular driver with regards to the UK sourcing produce from other countries. And climate change and environmental degradation was not only a risk for domestic food production, but also that of key sourcing regions. If domestic production is threatened by these factors, looking to source affected produce from overseas clearly risks displacing the environmental burden of current production patterns onto other regions, which will also be struggling with the very same risks. This is but one example which serves to highlight the crucial need for a global response to the management of agroplastic use and waste. So what are the policy and market driver gaps when it comes to the international development of agroplastic use? So at the global level, there is currently no global regulatory framework to coordinate efforts to manage agricultural plastics across their life cycle. As Richard mentioned, in response to the lack of coordination and complexity of the issue, FAO released an assessment in 2021, and following a decision at the 2022 Committee on Agriculture, the FAO is now developing a new instrument, a voluntary code of conduct for the sustainable management of agricultural plastics. To complement this, the ongoing negotiations for a new global plastics treaty, initiated by Resolution 514 at UNEA, offer a chance to also effectively manage agroplastics at the global level. It's essential that any new global governance framework on plastics, that there are provisions to allow dedicated programs of work on specific and complex sources of plastic pollution, agroplastics included, allowing stakeholders and right holders across the value chain to input into future policy decisions. When it comes to national level policy and market drivers, I will draw from our research on the UK landscape. Our findings show that as of 2005-2006, all devolved nations within the UK, within their waste management regulations, they also apply to agricultural waste. And as of 2019, Scotland and previously England and Wales have a ban on burning and burying agroplastic waste. Farms are now required to dispose of this waste through recycling and reprocessing routes. However, other than this one, albeit unsupported measure, given a lack of recycling infrastructure, UK policy specifically addressing agroplastic use and pollution is distinctly lacking. Some examples include the UK government deciding not to pursue a mandatory extended producer responsibility scheme for non-packaging agroplastic waste in 2010, despite such measures ensuring better collection and recycling rates. UK reprocessing agroplastic waste statistics currently stand around about 20-30%. Devolved nations have yet to enact an oxo-degradable ban, such as the EU, despite this type of polymer being highly damaging as it does not fully degrade and used as an alternative type of mulch. And even product requirements, including mulch thickness guidelines to reduce breakage and soil contamination, as is now the case in China, for instance, is not readily available. When it comes to market drivers, one might ask why we would look at the grocery retail sector, for instance, when it comes to agroplastic use. And this is because the food and drink retailing sector is by far the main final distributor of food to the public and the largest buyer of produce in the United Kingdom. Its purchasing and market power and subsequent responsibility means that its sourcing and product requirements can either hinder or enable agricultural practices that could reduce agroplastic use and pollution. From surveying the top 10 UK retailers on plastic use in their supply chain since 2018, we found that as of 2022, measurable objectives, supermarket-led sourcing policies, and adequate funding for scaling solutions are yet to be established by the UK grocery retail sector. However, all supermarkets surveyed recognise the need for a sector-wide initiative dedicated to agroplastic pollution. More supermarkets require certain suppliers to follow third-party certification standards or voluntary schemes compared to when we first surveyed them. And there has been a measurable shift in awareness, project and trials, but these are not necessarily matched by concrete action nor supported by enabling government policy frameworks. For timing's sake, I will not spend any time going into any of the other reports we have published in the Cultivating Plastic series, but if of interest, it was just to highlight how we have looked specifically into the environmental and human health harm that can stem from agroplastic use, showing how agroplastic pollution can leak into different environmental compartments from affecting soil quality and including aquatic and marine environments and life. We also highlight the main issues with regards to human health when it comes to mismanagement and agroplastic waste handling. We also look at particular issues with regards to agroplastic waste mismanagement and criminality, especially given agroplastics' high rate of disposability and lack of recyclability. We look into instances of dumping, burying, burning, and illegal export of agroplastic waste across the UK supply chain, as well as policy loopholes that mean that these continue to occur despite them not necessarily being noticed. And last but not least, within our last report that's yet to be published, we're looking into issues surrounding potential agroplastic alternatives, namely oxodegradables, biodegradable mulch standards, and microplastic contamination of sludge. And just to wrap up, agroplastics are inextricably linked to food production. The nature of this essential service means the environmental impact of its production must not endanger human and environmental health or the resilience of food production for current and future generations. Again, for timing's sake, I will not go into any detail with regards to the specific recommendations we identified as a result of our research, but what I hope this slide serves to demonstrate is that there's no single solution to this complex material problem. Options need to be assessed for each material design and application, location, and climate. However, this complexity should not be an excuse for inaction or lack of engagement. Thank you.
Thank you very much, Lauren, for this very interesting and comprehensive presentation that actually very well frame the problem with a good level of detail. Yes, I'm now pleased to introduce the next speaker with a presentation titled Knowledge Requirements for Making Inventories of Use and Waste Management of Agricultural Plastic. The person that will give this presentation is Professor Dimitris Briassolis, a colleague of mine. We have several collaborations on the go. Dimitris is professor at the Agricultural University of Athens in Greece and has several decades of experience in research and development. He's fellow of the National Foundation Scholarship of Athens from 1970 to 1975. He's a PhD in agricultural engineering from the University of Illinois. Dr. Briassolis has several publications and awards to his credit. He's member of the American Society of Civil Engineers, the European Society of Agricultural Engineers, the Greek Society of Theoretical and Applied Mechanics, and the Greek Society of Computational Mechanics. He is a recipient of the 2012 European Society's Agricultural Engineers Award. He produced important seminal work on the inventories of agricultural plastic. Please, Dimitri, the platform is yours.
Hello, everybody from Athens. Do you see my presentation?
Not yet. We see you in the camera.
You don't see the presentation?
Not yet.
I don't know. I have shared the presentation.
I can check.
Hi, Dimitri. There's a share button next to on top.
I did that, and now I have the option stop sharing.
Oh, maybe you can stop sharing and share again. So just share and your screen.
No?
No.
Is the previous presentation stopped sharing?
Yes.
So
you might have multiple screens. Then if you can, you might have to share.
I have
all.
Stopped again. Now I have the option open share tray. Okay.
No, not that. You have to share screen, or you could send us the presentation and we can share it if it's.
Yes. In the meanwhile, maybe
What is the share screen?
I suggest maybe Dimitris, you can send by email your presentation to me or Dia, so we can take your talk later, and so we have some extra time to fix the problem. I will move on with the program with the next speaker. Hopefully this is okay for everyone. Yes, I'm pleased now to introduce the next speaker, Rachel Hurley, Dr. Rachel Hurley. Rachel is a colleague of mine at the Norwegian Institute for Water Research. She has an extensive experience and expertise in the study of plastic transport, fate, and behavior in aquatic and terrestrial ecosystems. She has advanced knowledge on terrestrial occurrence and impact on micro and nanoplastic through several seminal publications. She is also an active member of several scientific societies and serves as a peer review for several journals in her field of expertise. She is the deputy coordinator of the European Finance Project Papillons, Plastic in Agriculture Production. Her presentation today is titled, "What do we know about the level and effect of plastic pollution in soil?" Thank you, Rachel.
Excellent, thank you very much. I'll just go ahead and share my screen now. Just checking that you can see that's okay.
Yes, we can see.
Wonderful. Excellent. So yes, thank you very much for the introduction, Luca. I'll be talking about what we know about the occurrence and effects of plastic pollution in soil, and I'll give a particular focus to the Asian context. So when it comes to the use of agricultural plastics, the Asian continent represents a major player. And this is largely driven by China, which is actually the biggest consumer of agricultural plastic globally. Although agricultural plastic is also increasingly used across the continent to improve productivity and secure farm economies. Across the world, agricultural plastic is projected to increase by 50% by 2030. And this is particularly driven by the increased use in Asia and also the increasing thickness of films used as agricultural plastics in this region. Agricultural plastics offer a series of benefits which can increase crop yields and reduce water or agrochemical use. However, there is growing concern related to the soil pollution generated by agricultural plastic residues. And there also remains a lack of data related to the usage, practices, and waste handling of agricultural plastics across Asia. So I'll begin by briefly summarizing some of the different applications of agricultural plastic relevant to the Asian continent. By far the most dominant typology are thin films used in protected cultivation systems. These include, for example, mulching films, low tunnel systems, and greenhouses. Additional applications relevant to the region include wrapping of silage, and also some specific applications, for example, as rain guards in rubber or latex farming. Nets are also extensively used. These are used to provide shade or protect crops from pests such as birds or flies. Particularly in arid regions across Asia, irrigation systems are essential for enabling agricultural production. And these often use plastic in, for example, the piping and also drip lines. Another sort of source of agricultural plastics, which is increasingly being used in areas such as China and Japan, relate to polymeric encapsulation of fertilizers, pesticides, and seeds. This is a plastic coating around some of these products, which can remain in the soil after use. Containers are also used across the region. This includes, for example, bottles, bags, and sacks of different types of agrochemicals or seeds, as well as the containers that are used to during the harvest to actually package the crops that have been produced. And finally, pots, trays, and bags related to cultivation of seedlings, saplings, and also mushrooms are also used in agriculture across the region. Beyond this use of agricultural plastic, there are also several additional potential sources of plastic and plastic particles to soil environments, including the application of sewage sludge or different types of compost products to land, the use of contaminated water supplies for irrigation, littering, and also atmospheric deposition. In terms of the potential for agricultural plastics to cause soil pollution, there are two sort of main mechanisms for this. First relates to the degradation of agricultural plastics during use. So this is the degradation of fragmentation into small particles due to exposure, for example, to environmental conditions and aging of the material. This is sort of more relevant for particularly thin films and products that are used, for example, over many seasons. And it's likely to also be more relevant in geographic regions that have high intensity weather patterns that might increase this kind of environmental degradation. The second is related to the mismanagement of agricultural plastic waste. There are actually major knowledge gaps related to the management of agricultural plastic waste across Asia and also the world. But it's expected that recycling is likely to be fairly low, and instead burying, burning or landfilling is probably going to be more prevalent. And then there's a chance then that these kind of accumulations of plastic waste can then degrade after use and input plastic residues to soils. Moving on now to talk about the levels of microplastic in soils. The vast majority of research on soil plastic pollution really comes from China, and that's across the world, not just in Asia. There's a growing mass of studies that have documented levels of plastic residues in soils, finding a wide range of concentrations, typically influenced by the extent of plastic exposure. And this includes concentrations up to those that represent fairly high concentrations from a global environmental perspective. Many of these studies identify thin film residues, and in particular mulching films, as a major source of plastic pollution to agricultural soils. And the reported concentrations are typically higher in fields subject to continuous mulching use over many years. When we look outside of China, the evidence is there are far fewer studies that we can draw from for evidence. I'll provide just some examples of other studies that have documented levels of microplastics or plastic residues in soils across Asia. So there are several studies that have identified plastic mulching and greenhouse systems as a source of pollution, and also groundwater pollution in Korea, for example. The increasing use of polymer encapsulated fertilizers in rice production has led to an increase in pollution in soils in paddy fields up to relatively high concentrations. Contamination has also been observed in Pakistan, which presented sort of medium to high concentrations of microplastics in soils. And there were also some studies in Mauritius and Iran that have documented some specific sources and specific dynamics related to the use of agricultural plastics and contamination of soils. Beyond this, there are also a small number of studies that look at microplastic levels in other environmental compartments and then point to agriculture as a source. However, there are many knowledge gaps persistent across the whole of the Asian continent related to the levels of microplastic in soil. More work is needed to identify the relative contributions from different potential sources of plastic pollution in order to tailor effective solutions. It's also important to consider variabilities in geography and agricultural plastics across the region. And this, of course, is very varied across the area, and we can't draw upon kind of broad conclusions from different geographic regions and apply these across the area. And also relevant for a global perspective, there are also discrepancies in reporting units and a lack of harmonization, which then complicates our ability to compare between data from different countries, different regions, or different types of agricultural plastic exposure. If we move on now to consider the effects of soil plastic pollution, there's a growing body of evidence now documenting effects on soil properties, on plants, and on soil organisms. Related to soil properties, this can include different physical, chemical, or biological properties. And there are actually variable responses that have been reported, indicating a high level of complexity when it comes to this topic. Effects on plants also differ based on the plant species or the different types of microplastic particles that were tested. And there's uncertainty regarding the uptake and effects of microplastics versus smaller plastic particles on plant species. For soil organisms, negative, positive, and negligible ecotoxicological effects have been recorded. And in a meta-analysis, there is a decrease in the number, diversity, movement, and reproduction of individuals reported across the world, but no real reduction in the biomass of soil organisms. What this all indicates is that there are lots of variables at play. This is related to the different endpoints that can be tested, but also the variety and the assemblage of microplastic or plastic residue types that can result from different forms of soil plastic pollution. This includes, for example, the size of the particle or the polymer type, which can influence the type of effect observed in different soil systems. There is also a need to consider indirect and knock-on effects as well. So small changes in a given endpoint, for example, a soil attribute, can actually trigger a knock-on effect that then propagates across the soil ecosystem. Soils are typically complex and self-organizing and can be resilient to a degree of this disturbance. But there is a need to assess thresholds associated with this resilience. And this is particularly important where plastic residues accumulate in soil over time. Many studies that investigate the effects of plastic pollution on soils tend to use high test concentrations. And as I previously discussed, there is missing data on the occurrence and levels of plastic pollution in many parts of Asia, and this can challenge the ability to effectively assess risk. However, there is already evidence emerging from China that soil pollution exceeds threshold for negative effects. So this is really an urgent topic that needs to be addressed in terms of these data gaps related to the occurrence of plastic pollution in soils and also the thresholds at which effects could be observed. Another important aspect related here is fate. So this may relate to, for example, the fate of agricultural plastics from a waste handling perspective. And there is a need for more data and a better understanding of how different agricultural plastics are handled at their end of life. And it's important here to understand the geographies of agricultural plastic waste generation across both time and space, but also how these relate to different and appropriate waste handling measures in different regions or localities. Second, fate can also refer to the fate of plastic residues in soils, so the small plastic particles that have then entered these soil systems. This is relevant to better understand which parts of soil ecosystems are actually exposed to plastic pollution and which may be vulnerable to the risk of pollution in terms of the threshold concentrations. There's still quite little research on this globally, but available studies demonstrate quite wide variability, often related to, for example, different soil types. Agricultural soils could accumulate plastic pollution over time and therefore potentially sort of increase these thresholds for environmental pollution. But on the other side, they may actually act as a source of plastic residues to other environments. And there's a need to kind of better understand this fate aspect when we talk about the levels and effects of microplastics and plastic residues in soil systems. To sum up, Asia is a major player in the use of agricultural plastics. Unfortunately, there are persistent knowledge gaps around the volumes and the typologies of plastic that are used for different agricultural applications and how this resulting plastic waste is handling. This is not a problem that is unique to Asia, but given that Asia is such a major player in agricultural plastic consumption globally, it's an important knowledge gap that needs to be addressed. Most of the available data is largely confined to China. This is relevant given that China is the largest consumer of agricultural plastic globally and documents quite high levels of plastic contamination in soils in some regions as a result of this activity. However, we need to investigate the levels and potential risk of soil plastic pollution in other parts of Asia as well. Evidence for the effects of soil plastic pollution are beginning to emerge, and it's a growing body of evidence both inside and outside of Asia addressing this. But as mentioned, the variability in responses that are observed in these different tests point towards a wide range of uncertainties and relevant variables. And there is obviously then a need for further testing to unpick some of the complexities at play here. And then we need more data on the environmental levels to identify if or when thresholds for negative effects may be observed. And we see already that there's evidence from China that this may be very soon and particularly relevant for the Asian context. This is relevant to produce relevant and appropriate measures to safeguard Asian agricultural production as well as global food security in the future. And with that, I would like to thank you for your attention.
Thank you very much, Rachel, for giving us this overview of what we know about the impact or potential impact of plastic pollution in soil ecosystems. So I think we solved the technical problem. We go back to Dimitris Briassoli's presentation on the knowledge requirement for making inventories of use and management of agricultural plastic. Thank you very much, Dimitris. Sorry for the technical issue we experienced before. The platform is yours. Dimitris, I don't hear your voice now. We can see the presentation though.
Dimitris, I'm sharing this presentation. You can just let me know next slide and I'll change it as you speak, if that's fine.
I tried again. Don't you see now the presentation?
We can see
No.
we can see your presentation from you just tell Dia when to shift the slide. Your presentation is now displayed.
Okay.
Yeah.
So hello from Athens, everybody. Knowledge requirements for making inventories of use and waste management of agricultural plastics. Which agricultural plastics? There is an estimation of 12.5 million tons of plastic products used every year in agricultural applications, most of them in the crop production and livestock sectors, according to a recent report by FAO published in 2021. These estimations are based on various sources, and the data refer to different reporting years. Now, major negative consequences from the use of agricultural plastics.
Excuse me, Dimitris, for interrupting. We don't see the slide progressing, Dia. Can you make sure we see the presenter side of it, not the full screen?
Yes, I can do that, but I won't be able to see Teams then. I just need Dimitris to say next slide and I will change it, if that's fine.
Yes, okay. I guess we are.
I don't see the presentation now.
Can you see it now?
We are now on the cover page. Do you want to move on?
Okay.
Can you see it?
Yes, next, please.
Okay, perfect.
Here I was talking about the amount of the agricultural plastics used at the global level, reported by this FAO report. Next.
It looks like this is an issue with the internet, with the network, but we are now on the page.
Now I see the bar with the shared camera. I don't see the presentation.
We are now on the slide titled Knowledge Requirement.
Yes, but I don't see it in the Teams.
Okay.
What happened?
It might be a problem of we have it on our screen, so I believe there's an issue with the network.
Can you share again?
It's already sharing. If you open the Teams.
I am on the Teams. Which slide are you showing now?
Knowledge requirements. What are the uses of agricultural plastics in different countries?
Major negative consequences.
This I can show that. That's
the third one. The third one.
Yes, I'm on slide 3 now.
Handling of huge volumes of agricultural plastic waste is a major negative consequence of the use of agricultural plastic, including technical, economic, organizational, administrative, legislative problems, and all this associated with significant environmental impact. Next, please.
Yep, it's on the next one.
Now, I have used some points from the questions to panelists to structure this presentation. I hope it's fine with everybody that. uses of agricultural plastics in different countries. Next, what agricultural plastic types and quantities, what agricultural plastic waste types and quantities, which legislation framework is applied to agricultural plastic and agricultural plastic waste. So these questions, next please, have the answer. No official statistical data are available for agricultural plastic and agricultural plastic waste at European level by Eurostat, neither at EU member states level. The situation is similar at international level, more or less. No legislation is established at a European Union level specifically for agricultural plastic and agricultural plastic waste. Of course, there are a few exceptions at national level. Next.
Yep.
Do we think that there is sufficient knowledge available for policymakers to make informed decisions? Next, note here, plastic-based agriculture is not bad or good to select. Next. Is it possible without reliable data to carry out research and studies aiming at optimizing the use of the various agricultural plastic categories and the sustainable agricultural plastic waste management at national or international level? Is it possible without reliable data to develop, building from a holistic approach, policies and strategies that aim at truly sustainable solutions at national or regional or international level? Next. However, there is sufficient knowledge available specifically for the policymakers to establish legislation at country, regional, or European and international level for recording officially statistical data for the various categories of agricultural plastic and agricultural plastic waste. Also for establishing special waste streams for the sustainable management of the various categories of agricultural plastic waste following the principles of the circular economy. Next. Next. The lack of reliable agricultural plastic and agricultural plastic waste data is not a problem of insufficient knowledge. It is a political gap. Its solution depends on the determination of the political actors involved. So, we consider reliable data as a prerequisite for developing sufficient knowledge. Next. Is this the slide 7 you're showing?
Yes.
Okay. Here are some points from these questions. Main knowledge gaps could be addressed by scientific research. Main knowledge gaps prevent the development of policies and strategies to improve the sustainability of agricultural plastics. Of course, we have several negative views about agricultural plastics, also mentioned by the previous speakers. Among them, misconceptions, terminology confusion, questionable claims, insufficient legal framework, actions and implementation, conflicting stakeholders' position and lack of knowledge, research results not exploited by the policy-making bodies. Next. Knowledge improvement requirements. We can select targeted research projects on specific open issues. Standard test methods and specifications to be established when and if needed. Legislation to be established for agricultural plastic and agricultural plastic waste. Certification and implementation. Research project outcomes to be exploited. Dissemination. These can be handled only in an integrated approach. Next. Next
Yep.
to slide 8, please. Finding alternatives. Next. Of course, finding and developing alternative, innovative, conventional and biodegradable agricultural materials, the sustainable agricultural plastic use and the agricultural plastic management are major important research challenges. Next. These challenges require that we focus on several issues: techno-economic sustainability, circular economy, functionalities, soil pollution, biodegradation, material recovery, environmental sustainability, bioeconomy. Next, please. Nature-based practices for agriculture. Next. Plasticulture can be developed in many different ways, including bio-based. It's not bad plasticulture at good natural ways. Next. The negative ways of the application of plasticulture include agricultural products without satisfactory functionality certification, misuse of agricultural plastics resulting in soil pollution, mismanagement of agricultural plastic waste resulting in soil pollution and environmental impact, lack of infrastructures for the management and valorization of agricultural plastic waste, lack of legislation and/or a lack of implementation of existing legislation, regulations, and directives. Next, please. The problem of agricultural plastic waste in Europe today includes burning of agricultural plastic waste in the fields with serious consequences with harmful airborne toxic substances, including dioxins, with negative consequences to human health and to the environment. Also possible danger for the safety of food produced. Next, please. Slide 11. Next. The European legal waste framework forbids uncontrolled burning or burying or discarding of plastics in the environment, plastics in general, and this includes agricultural plastics. Next. The polluter pays principle states the cost of management of waste must be borne by the holder, the previous holders, or the producer of the product from which the waste came. Next. These European Union laws are not applied in most cases of agricultural plastic waste management. Next, 12, slide 12. Back in 2006, a European project was funded on labeling agricultural plastic waste for valorizing the waste stream. Next. The objectives were to develop standardized procedures and integrated methodologies to label the agricultural plastic waste streams to facilitate their routing to the best alternative processing and final valorization. Next. This project resulted in a European management scheme for agricultural plastic waste, which was developed and proposed to the European Commission to three general directives. The system is environmentally friendly and economically viable and technically feasible. The main elements of this scheme includes design of optimized infrastructures and operational protocols at the European level, labeling scheme, collection schemes, quality control, traceability, technical specifications for valorization of the various agricultural plastic waste categories, proposed financial scheme with the participation of the stakeholders. Next. 13. Next. The project proposed simplified universal specifications for valorization of agricultural plastic waste. Here you see two sets of qualities of mechanical recycling, producing of recyclates, best quality of recyclable plastics, and then of products, the second quality. Also specifications for energy recovery of non-recyclable agricultural plastics. Next. And also a lot of work has been done on the development of alternative agricultural plastic products biodegradable in soil. Here in the middle picture, you see the experimental field of the Agricultural University of Athens, and you see that some of the low tunnels are a milky color. These are biodegradable low tunnel films, 30 microns thickness. And under the low tunnels, there are also biodegradable soil emulsion films. Next, please. Thank you very much.
Thank you very much, Dimitris, for this important presentation. You correctly highlighted existed of important knowledge gap, but you also managed to introduce basic building blocks. So what we know and what are the available data we can build on. We will have a question after the last presentation. So I'm now pleased to introduce our next presenter and the last for this series of talks, Dr. Smita Mohanty. Smita Mohanty is a principal scientist, head of the Central Institute of Petrochemicals Engineers and Technology, CPET, Department of Chemical and Petrochemical, and institute. And this is an institute under the Ministry of Chemicals and Fertilizers, the government of India. Dr. Mohanty has more than 18 years of experience in teaching, research, and technical consulting in the polymer science field. She has been the key to industry connect, bridging academia and industry. She has been the author of more than 200 international publications. So thank you very much, Smita, for being with us today. And your presentation is titled Fostering Sustainable Agriculture with Plastic, a promising solution for the future. The platform is yours.
Thank you, Luca. I think I need to share the presentation. I'm not able to share it.
Hi, you can see the share button next to leave.
Yeah, I have seen that. There is some problem. I don't think I'm able to share it. Maybe 1 second. I'll just.
Okay. If you click share and then just the screen, the first screen, it should show up.
I think there is some problem.
I would suggest to send the email with the presentation. Maybe in the meanwhile, I would take the chance to address one question, so to anticipate while we wait for your presentation. And the question is for Rachel Hurley. Was also the question that one of our member of the public has asked. How can we imagine a future where, for example, risk assessment of particles in soil, microplastic in soil, could be part of a regulation? What type of knowledge and what type of studies we need to take into consideration? Rachel, maybe you can answer this question before I give the answer to Smita. I see the presentation now, but...
Are you able to see my presentation?
Yes, Smita, sorry, just 1 minute. We will let Rachel reply to the question, then we move back to you. Thank you so much.
Yeah, thanks for that, Luca. Yeah, I mean, it's certainly a challenging question, and it doesn't just relate to soil plastic pollution, but all forms of plastic pollution. And we can see this in the fact that there aren't, you know, a wealth of systematic frameworks related to risk assessment that have emerged. This is something that is being discussed quite a lot by the global research community. In terms of relevant for agricultural plastic residues, for example, some of the things that we're still missing are like studies that target onto very relevant particle typologies. So using, for example, test materials that derive from relevant products that are used in agriculture, and also present a range of characteristics that relate to those that are actually observed in in environmental settings. So, for example, a relevant size distribution of particles. And this will help to target some of the evidence for exceeding thresholds and identify some of those thresholds relevant to specific particle types that represent important sources of contamination. So that would help to speed up some of this. But I think the main aspect is to communicate about risk carefully and to make sure that we don't exaggerate risks without evidence. So it's obviously a very hot topic and very good to approach it with some care and consideration.
Thank you very much, Rachel, for this view over the future of risk analysis, risk assessment, and risk management. That will be an important, possibly an important component of regulation, including in a recommendation for policymakers. And now, finally, I'm pleased to reintroduce Smita Mohanty. Thank you very much. Sorry for this technical problem. We can see your presentation titled Fostering Sustainable Agriculture with Plastic, a Promising Solution for Future. Please.
Thank you, Luca. So my topic is on fostering sustainable agriculture with plastics, a promising solution for future. Now, if you see, all of my previous presenters have already shared that what are the applications, primary applications of plastics in agriculture, whether it's growing pots or propagation trays or boxes, cases, fixed and portable tanks for storage and bulk transport, packaging, spare parts, components for entire the drip laterals and other things for irrigation systems like fittings and spray cones. Now, if you see the commonly used plastics, if you see the 80% of it belongs to the commodity range of plastics, which we call it belonging to a plastic fraternity, like you have low density polyethylene, linear low density polyethylene, HDPE, polyvinyl chloride, polypropylene. Then you have 20% contributing to different other categories of plastics, which includes your PMMA or your polycarbonate or your FRP or polyacetals. Now, if you see the primary applications of plastics in India, in agriculture especially, you can see globally out of 359 million tons of global plastic production, we have only 3.5% contributing to the agricultural plastics. And out of that, if you see, the majority of them comes out to be the greenhouse films, then followed by your mulch films, then your silage and your non-films, tree guards, then your fertilizer coatings. Now in Asia, if you see the annual usage of plastic film on permanent cropland, Asia tops the list. Now in India, we are way behind. We have only 1% contribution of these plastic films in the agricultural sector, if you see out of the total plastic production capacity. Now, let's see how much is the average lifespan of a plastic product in crop production. If you see, if you look at the statistics, then the pond liners tops the list. That means the lifespan is ranges about 48 months, which is followed by you have your greenhouse films, which is near about 45 months, then followed by your irrigation drip laterals and other things, which is near about 24 to 26 months. Other things like your mulch films, etc., this lasts for exactly for 6 months to 10 months to 8 months period. So that is where the problems associated with the agricultural plastic pollution comes in, because these mulch films or pesticide containers or your bags or your seedling plugs, plant pots, etc., they have a limited lifespan, and post which there is a problem of the environmental pollution. Now, coming to that, one of the speakers highlighted that we need to have some of the biodegradable plastic systems for sustainable agriculture. So what are these biodegradable sustainable agriculture systems? These includes your alternatives for your mulching and row tunnel covering. It presents the importance of composting as a ecologically important tool for sustainable agriculture and waste management, proliferation of soil biota, and need for additional chemical inputs. So what we get in case of your normal conventional polyolefins, like post its harvesting cycle, We need to take out all the weathered plastics, we need to collect it and then go for recycling mechanism, or it causes some of the agricultural pollution. So that has led to the development of these sustainable biodegradable plastic systems for sustainable agriculture. Now, what are these materials? Basically, it constitutes of all kinds of your biodegradable polymers or your compostable ones, like for example, your PLA, PBAT, PBSA, etc., wherein you can formulate your things and you can see how best it matches to your requirements. What is the end of the crop cycle, how you are going to address it, in what way you are going to focus on it. So these things can be applicable in your agricultural plastic production. Now, this is a snapshot of the currently work which we are doing at CPIT. I represent from Central Institute of Petrochemicals Engineering and Technology, where we develop a lot of alternative formulations, starting from biodegradable or mulching films to your seedling bags to your row tunnels. This is a specific applications concerning to PLA and PBAT based films where we formulated it. And as you can see that it was subjected to real field trial, and a comparison was made with the conventional polyolefins, with the conventional systems which is already persistent, and we had seen that how well were the plant growth rate, how well it was in the soil, and what happens exactly after the end of the life cycle. Now, as you can see that what we did after the end of the life cycle, we did the isolation and analysis of the microplastics in the soil post the field trials. So what we did, we analyzed, we took the soil which is 6 months old, we took the soil which is 8 months old, we took the soil which is near about 18 months old also. How long these microplastics were persistent. And to the best of our knowledge, what we detected at the end of the crop cycle, these kind of biopolymers were also still persistent in the soil after 6 months, even after 8 months, although the concentration is reduced, but still they were persistent in the soil. So the problem is that we need to be careful in deciding that what kind of plastics exactly assimilates into the soil, whether it is really impacting the earthworm reproduction cycle, whether it is really impacting the soil fertility. Those things needs to be analyzed. The studies are underway and we are trying to come out with appropriate results as far as possible. Then one more is the development of a double layer mulch films towards sustained release of the nutrients to the soil. Now, here what we did, we used a PLA based core layer as well as a thin outer layer of polyvinyl alcohol, which is also a biopolymer. To it, we added some amount of nanosulfur, where we were studying the rate of your germination and the plant growth rate with the effect of a nanosulfur. Here what happens, there is a sustained release of these chemicals or their agro-based fertilizers into the soil. So instead of using 50 kg of soils, maybe you can go for 5 grams, 5 kg of your nutrients, macro to micronutrients inside the soil, and you can go for a productivity of the same crop yields. This is another case of your case study of a non-biodegradable pea-based root trainer, which is practically utilized in India across the country for root trainer as root trainer applications. Here what we have done is that we have taken a case study of polylactic acid with wood floor, polylactic acid with natural sisal fibers, then all the wood dust we fabricated, the all kinds of root trainers with them, and then subsequently we have done the studies. Absolutely the growth rate of the plant was not affected. But what we need to examine is after the cycle, after the crop cycle, what happens, what is the end of life of these kind of agricultural products, plastic products. Then these are the composting facility, as you can see, addressing the compostability of compostable polymers. We have a composting facility also, like at the end of the day, what exactly you do, the remnants which is present in the at the end of the crop cycle is being taken to the composting unit, and the soil fertility is being examined, how well it assimilates, in what way it assimilates. These are the different categories of materials we try to assess, and how well it goes into the soil and it doesn't affect the wormy and other composting units. Then Apart from that, now a popular thing which has come up in recently is a hydroponics based farming where plastics are being broadly used. What is this hydroponics based farming? It is basically a horticultural pathway wherein you don't require any kind of soil. You can grow with mineral nutrient solutions in an aqueous solvents. And the majority of the plastics which are being used are basically is your high density polyethylenes or your polypropylenes, where India has got a market strategy of growing different categories of your plants, and this is going to touch the CAGR of about 26% to reach about 10,500 metric tons by 2023. Now, as you can see that we can grow manifold crop types, manifold systems also we can go, and various categories of equipments we can also connect to it. So how these are, what exactly this hydroponics includes? It can have water, it can have PVC pipe, which is a growing medium for plant support. It can have a pump, nutrient gallon tank, a hydroponic system where you have incorporate all your dissolved nutrients, cups and grow trays, trellis, as well as sunlight or grow light to grow it. So these are the different layers of hydroponic parts which has become quite popular in the regions where you can grow many categories of crops without using the soil, and you can use the plastic based systems in it. Now, so here the polymers can be used as a supporting medium, they can be used as a growth tray, they can be used as a nutrient water as well. Apart from that, there are also advanced polymers where it is used for different categories of applications, like we have cellulose, chitosan, then we have PVA, we have brush types of polymers, we have different poly then PAA, etc., which can be also used for different categories of systems, where you can have different categories of agrochemicals which is being used. As you can see in my slides, that you can go for a combination of different biopolymers where you can use different carriers starting from your metallachlor or imidacloroprid, or you can use for ametrine, atrazine, etc., which you can incorporate into your polymeric system, and they can act in a diffusion control mode or in a slow release, as well as the micronutrients is being established or is being released into the soil, and the plant also grows. So in response to this, we have different categories of polymers, like for example, we have stimuli responsive polymers, as well as we have also super absorbent gels. Now, what are the functionalities of these categories of polymers? We combine those polymers and a macronutrient and leave it into the soil stream. So with the balance of the pH, with the change of the pH, these micronutrients are being released into the soil. So this is the overall mechanism how we can progress using the polymers and the plastics for agricultural growth. Apart from that, these are some of the super absorbent based systems wherein you can see the sodium alginate as well as the copolymer chain, wherein the silica nanoparticle is being incorporated, and you get it in the formation of a myceli, which is released into the soil, and with the acting environmental conditions, whether it is in the change of the pH or with the UV light, it dissociates and slowly the drug is being released. So by that way, you can also control the release or rate of your fertilizer stream into the soil, and the growth of the plant can also be tailor-made. So these are some of the things fostering with the case of the agriculture. So summarizing, plastics, yes, plastics are problematic because they are ubiquitous in nature, but if we can manage the plastics through recycling, or if we can manage the plastics through different systems, then plastics can also promote the agriculture production. It can increase the crop yield as well. I would like to thank the entire organizers for giving me an opportunity to speak. Thank you. In case of any questions, I'll be happy to answer. Thank you. You are muted, Luca. You're muted.
Apologies. Thank you very much, Smita, for this interesting presentation and enter into the detail of technology and knowledge we have. I have a few questions for the speakers now, and we don't have much time, so I would ask you to provide a concise answer. First, for Smita, since we just heard your presentation, what is the opportunity for small-scale farmer to assess some of this technology whenever a technology has been validated and tested to and show it is a sustainable solution to reduce the potential for plastic pollution? What is the option and the opportunities for a small-scale farmer, for example, in India, to assess this material and to handle also the waste that can potentially emerge from the use of these materials?
First thing is that what I referred to is biopolymers. Yes, the cost of the biopolymers is quite high, expensive, but what we are doing is that we are trying to formulate different categories of polymers incorporating many natural fillers, which is readily available fillers. Like for example, in India, starch is plentifully available. So with starch and polylactic acid or PBAT range of polymers, we can definitely come out with the formulations. Similarly, with regards to the root trainers, which is normally with the polyolefins, we can go for, in the earlier days, egg crates were used, but now we have come out with a solution where sawdust and minimum quantity of biopolymers is being used and you can grow your plants. Hydroponics is another area where you can use the waste PVC pipes. I mean the PVC pipes, with that waste PVC pipe with minor modification, you can grow your plants without having the soil interference. So these are some of the accessible technologies which the farmers can readily use it. Other than that, we can also suggest for recycling of the end of life polyolefins, which is a very tough task to collect because India has got plenty of UV radiation, and so collecting all these plastics post end of life crop cycle is a very tedious job. But still, if we collect it and if we have ready-made recycling plants in place, then we can go for different categories, like starting from small pots to trays where the farmers can access it.
Thank you very much. My next question will be for Dimitris and will be a little bit broader question. Dimitris, what do you see should be the role of industry in framing a sustainable way and circular maybe way to use agricultural plastic? Can you give your opinion on this?
Yes, the project I mentioned before, Label Agri Waste, was carried out by 18 partners from around Europe, including the Association of European Plastic Converters, the Association of European Plastic Recyclers, several industries participating in pilot tests for recycling, for energy recovery, and so on. And of course, universities and research groups, and also associations of farmers. At the end of this 4 years project, we had a unanimous agreement on the proposed scheme, which I presented to DG Environment, DG Agriculture, and DG Enterprise. The participation of the industries is necessary in the research project in order to be in touch with the stakeholders like farmers, the government bodies and so on, and also with the researchers, so that there is a common knowledge built up and then disseminated. Without this way of integrated approach, then we see many problems of misconceptions on the part of the farmers, on the part of the industries. Then there are claims that the universities do not produce something useful for the policymakers. On the other hand, we experienced just the opposite. We promoted a solution, a proposed solution, which could be open to public discussion and modified, whatever, improved. But there was absolutely no reaction on the part of the European Commission, and instead we had the suggestion by DG Environment that we should lobby to the European Parliament. The researchers, is that the work of the researchers? So there are several organizational issues at the political level to be solved. And then I think in technical terms, this is what I can answer. It is possible to have a good collaboration with industry and with the other farmers and so on, and develop a very well-functioning and organized systems for good environmental friendly and in compliance with the circular economy system for the valorization, not just management, valorization of recyclable agricultural plastics. And the example is at the Valor in France.
Thank you very much. We can see there are different components. There is a political component, there is a technological component beyond. So we need to solve a lot of knowledge gaps. That's why we are convening here today. My last question for this section is for Laureen. Laureen, we read on one of the EIA report about cases in which farmers in the UK are burning agricultural plastic waste. Unfortunately, we know that this is a common mispractice, unsustainable practice that happen in Europe as well, in South Europe, for example. I'm Italian. I can confirm that. How do you see, how can the international community and policy address, and how can a regulation can enforce instruments that prevent these practices, not only in Europe, but keep in mind also the situation on the global south, in countries that are seeing now an expansion in the use of agricultural plastic.
Thank you. Thank you very much for this question, and also for Titi for asking it. So our findings, I'm going to draw examples specifically from the United Kingdom, and I appreciate that they might not necessarily be reflective of every situation in all countries all over the world. But we identified 4 potential solutions, but of course we're very mindful that there are many more also. So within the UK, for instance, one of the solutions would be the mandatory reporting of agroplastic use and waste. And the reason for this in the United Kingdom is because there is a lack of mandatory reporting. And what this has done is it has resulted in a policy loophole in the UK. So farmers must attain a waste transfer note to be able to show that they're reprocessing all of their agroplastic waste, which they're legally required to do. And the problem is that they simply need to pay for the minimum amount of agroplastics required to be able to get one. And what this means is that the UK government saw that they're then able to mismanage, including burning agroplastic waste, the remaining agroplastic waste that they produce on farm sites, and that this isn't necessarily being noticed. So the first would really be mandatory reporting to be able to actually monitor what's being placed on the market. The second would be adequate funding of the Environment Agency, which is the government agency that ensures that environmental laws are being followed within the UK. They don't currently have enough capacity to effectively enforce and monitor the issue of burning. But it's not simply a matter of mandatory reporting and enforcement. So, for instance, in the UK, the burying and burning of agroplastic waste can result in fines of up to £50,000, in additional to legal and environmental cleanup costs. This isn't nothing. This is quite a significant cost and quite a significant risk that farmers are facing by burning agroplastics. So, what we really need to do here is take a step back and look at the system at large to see why farmers are burning agroplastic waste despite the high costs that they might face by doing so. And one of the solutions we are suggesting is to bring about mandated extended producer responsibility schemes for agroplastic waste, so that the onus of collection and recycling costs are not placed on farmers and growers alone. And this is also important to then look at grocery retailer sourcing policies, who in and of themselves might be resulting in unnecessary agroplastic use. And very quickly, last but not least, when we're trying to close these policy loopholes to stop burning at the national level, it's also incredibly crucial to make sure that any measures don't then result in any illegal mismanagement occurring by other methods. And within the UK, for instance, this would then be potentially what we've seen also is an uptick in illegal export of agroplastic waste. So then other countries have to bear the brunt of this issue as well.
Thank you very much. Yes, of course, you touch upon several important points, including, of course, the issue of transporting plastic waste across boundaries. It would be very nice to continue this discussion. Unfortunately, we have limited time. I am now, before I will introduce a survey that IKHAPP is organizing to collect feedbacks from all of you experts and representative officials that are present today, to give your perspective, your idea, to express your demand for knowledge gap. Before we move to the presentation of these surveys, I'm very pleased to introduce the next section, which will be a panel discussion about this topic. And we have a number of very important panelists. First of all, the section will be moderated by Giulia Carcasci. Giulia joined FAOs in 2021 at the office in 2021, in the Office of Climate Change, Biodiversity and Environment, as an agricultural plastic and sustainability specialist. She is also part of the team developing FAO's voluntary code of conduct that Richard introduced earlier today on sustainable use of plastic in agriculture. She has been working on policy advice, country support, and knowledge creation to promote a more sustainable use of plastic in agriculture. Giulia will moderate this section. Giulia, if you allow me, I can also introduce all the other speakers and panelists. The first one is Dr. Divya Signa. She's a scientist and department head at the Central Pollution Control Board under the government of India. Dr. Signa has also worked with international organizations such as the United Nations Development Programme, UNDP, and the World Bank on various environmental projects in India. The next panelist is Satish Signa. He's the associate director at Toxic Link, a leading environmental group working on issues of waste and chemicals in India. He has been responsible for several large-scale research projects and campaigns on environmental toxicity issues, and has also contributed to policy formulation on waste. He has contributed extensively to the drafting on e-waste and municipal waste rules in India. The next panelist is Professor Defu He. He's a prominent researcher in the field of plastic pollution. He's a research director at the East China Normal University in China. He has been authoring a number of very important research papers, especially including on the topic of plastic pollution in soil and related ecotoxicological effect. Because of this, he has is one of the prominent figures on micro and nanoplastic pollution, including also aspects related to soil waste management. Dr. Nitya Manyari Mishra is the next panelist. She's a scientist at Odisha University of Agriculture and Technologies in India. Her expertise is highly showcased in fields of nutrient management, soil fertility, biofertilizer, organic farming, and agriculture. She has several publications as an associate editor of ePlanet, a multidisciplinary international journal. Next, last but not least, we have the contribution of Satinya Anand. He's a children and youth engagement advocate in environmental governance. A recent graduate in law and commerce from Tamil Nadu National University. She is an advocate role with the Bar Council of Tamil Nadu. She currently facilitates policy coordination of children and youth major group to United Nations Environment Program. So thank you very much to all these prominent panelists, and I leave the word to Giulia to ask questions to our guests. Thank you very much.
Thank you very much, Luca. Can you hear me and see me well?
Yes.
It's a pleasure to join this webinar and moderate this panel. In the interest of time, I will ask each panelist one question, and then we will have some time for questions and answers from the audience. Please remember to add your questions to the Q&A chat, specifying who your question is directed to. I'm also asking the panelists to please be mindful of time and limit each answer to 3 minutes. My first question is for Satish Signa from Toxic Link. Could you introduce yourself and the work you do? And can you tell us about the use of agricultural plastics in India? And also, what are, in your opinion, the main knowledge gaps that could be addressed by scientific research, including aspects related to the management of agricultural plastics waste? The floor is yours, Satish. Hello.
We cannot see you, Satish. Maybe we have some technical problem. Maybe we can move on to the next question before try to retrieve Satish.
Absolutely. I will then move on to Santilla. Santilla, can we briefly check if you're online, you can hear us and see us? Perfect. Hello, Santilla. Nice to see you again. Thank you for joining. Again, Santilla is policy coordinator from the Children and Youth Major Group to UNEP. Could you introduce yourself, the work you do, and answer the question? What knowledge gaps do you think exist that prevent the development of policies and strategies to improve the sustainability of agricultural plastics, especially in relation to India? And how can market-based and/or policy-based measures reduce the environmental impact of plastics? Thank you.
Thank you, Julia. It's nice to see you again. Hello, everyone. I'm Sandhya. I'm based in India. I'm an environmental advocate that's enrolled with the Tamil Nadu Bar Council. I also coordinate policy with the Children and Youth Major Group to UNEP. So that's what I do. My earlier work in this context has been analyzing the legal framework, especially in relation to plastic mulching in India. So that's my background in this space. So on the questions that Julia has asked, I think I will put them in 4 points. One of them is the science that we do have. The questions that when it comes to policy making decisions is whether those science is actually broken down so policymakers and people who are working on them is able to access them. It's not, that's one thing that I think is still a gap. Either it exists or it's not freely accessible. So that's one. Second, I think is that we still need more data or scientific information on what plastics need to be governed in terms of agricultural plastics, because the current scenario in India is that we only regulate plastic packaging or plastic sheets or primary or secondary and tertiary packaging, but it's not more so. We've not gone into, let's say, an extended producer responsibility that has been implemented in India and that's currently in force and is trying to be implemented, is only focusing on plastic packaging. We haven't gone beyond that. We've just started. So I think we still need science to govern us or help us with that. What do I mean when I say that science needs to help us in that context is, let's say we're doing, how do we deal with the issue of plastics? Is one of that is recycling and reuse of plastics and so on and so forth. And also in line with the polluters pay principle, we also levy environmental compensation. So when it comes to policy, we also have to determine how do we then determine what is the environmental compensation and for what specific purpose. For that, I think we need cost benefit analysis of what plastics are being used and how they're actually affecting either soil, human health, air, and what is the cost that we're having to face. So I think that still need to be something that we have to address. But I also feel like because environmental or the agriculture sector is a very vulnerable sector in India, the political scenario having to reach out of anything that is adversely impacting agriculture is sort of taken in a serious note. So the policies that are either coming out, I think would be better based when they focus on producers or plastic processing units and so on and so forth. And that's one thing, I guess, yeah, that's pretty much it on the question. I hope that I didn't exceed the time.
Thank you very much, Santilla, for such a complete, concise answer, pointing out many valuable points, also how the lack of information is not necessarily a good reason not to start acting on those policies that we know being effective, such as EPR schemes, and hopefully research will also, further help us while we start developing these policies. And Satish, can you hear us now? Do you want me to repeat the questions? The floor is yours. I'm afraid we cannot hear you. Could you try again? I think you are unmuted. Thank you, Satish. I think we're having some technological issues. And maybe can I ask if Dr. Dafu He is online and can hear us and see us?
Yes, yes. Okay. Hi.
Yes. Hi, thank you for joining us. So Dr. Dafu He is Research Director from East China Normal University. Could you introduce yourself and the work you do and answer the question? How important do you think it is to find alternatives to the traditional and fossil-based plastic products used in current agricultural plastics? And also, how important do you believe plastic is to the future of agriculture in China? And do you have concerns about the effects of soil pollution on agricultural productivity? And apologies, Satish, for the issues. I hope that in the meantime we'll be able to solve them and give the floor after the intervention from Dr. Dafu He. Floor is yours.
Yes, thanks for your introduction and your question. I'm a research professor in the East China Normal University in Shanghai. My work is mostly about plastic and microplastic pollution in soil, especially in agricultural soil, and also about the ecology, toxicology, ecology effect of the microplastic. Your question about how important do I think is find the alternative to the type of plastic products in agricultural practice? Yes, finding the alternative to the conventional plastic products is very important. The most reason is that the continue and the havens relies on the conventional plastic, such as PE and PVC and other in agriculture, pose a long-term threat to the environment, the food security and even human health. It can be discussed in several aspects. Number one is plastic pollution can lead to the soil degradation. The soil degradation in turn can reduce agriculture productivity. Microplastic can be formed by the fragmentation of the larger plastic piece and accumulate in the soil and adversely affect the soil structure, nutritional cycle, and the growth of the beneficial microorganism. This can then affect the ability of the soil to support the health crops growth. Number two is plastic can harm the biodiversity, including the various organisms that contribute to the healthy agriculture system. For example, the microplastic have been found to be harmful to the earthworm. Earthworm plays a crucial role in the maintaining soil structure and fertility. So, moreover, the plastic waste also can negatively impact other soil animals and even the wildlife, potentially disrupting the ecology balance. This balance is necessary for the particular agriculture. Another consider is that they are concerned about the potential human health impact associated with the plastic pollution. Microplastic and the social toxin can accumulate in the food chain and pose the potential risk to human health through the consumption of the contained food products. So the food safety is a big issue. So also more research is needed to the food understand the risk is necessary to consider alternative to minimize the potential for harm. So based on this consideration, it is essential to explore and promote the alternative to the conventional plastic in agriculture. Some potential alternatives have been introduced by other speakers, including biodegradable plastic, bio-based plastic, and other no-plastic materials like paper and natural fibers. However, it is most to note that not all the alternatives are equal, sustainable, or effective. For example, in our research in recent months, our experiment both in the laboratory or feeders farmers show the release of the microplastics during the degradation of the PA or PBAT. So more microplastics are released into the soil. Another concern is the release of the plastic additive. You know, the bioplastic have a short degradation cycle and high degradation speed. Therefore, more plastic additive would release into the soil. But according to our knowledge current, these additives are not all no toxic to the soil's biota and soil environment. So the potential impact of the biodegradable plastic and other alternatives should be considered. Therefore, we should develop really environment-friendly alternative to conventional plastic. So in one word, price market research and industrial stakeholder must cooperation to identify the really environment-friendly alternative and developing suitable alternative that can effectively replace the conventional plastic. So I think it is very important to minimize the environmental harmful of the agricultural plastic. This is my answer to your first question. Yes. There another question? So what? That all? Yes.
Thank you very much for your answer.
All questions have been answered.
Yes, okay. Let me share again the second question, but in the interest of time, I would really appreciate if you could try and answer in not more than a minute. We have 2 more panelists to hear from. So the second question was, how important do you believe plastic is to the future of agriculture in China? And do you have concerns on the effect of soil pollution on productivity? Thank you.
Yes, China is the world's largest products and consumers of the agricultural plastic, and so China is also should play a critical role in addressing the plastic pollution in agriculture. For example, the use amount of all the agricultural film reach about 2 million tons every year in China. Just the Richard has mentioned the 8 million tons total agricultural plastic in China. If we only consider the March, about 2 million tons in China. So I think this no accurate statistics data, but it is estimated the number is about 20% to 30% of the total the word or number of the agriculture film. So no problem. The plastic is very important to future of agriculture in China. We can see it's very popular to use the plastic in China in each country, each provinces. You can see the lot of the film, much film, greenhouse and other agriculture. So you know that China feeds about 21% of the world's pollution, with only 7%, about 7% of the world cultivable land. So in this process, the use of the IKHAPP Plus have played an important role to feed the so many population. So this is a big contribution. However, there are also a concerns about the negative impact of the plastic pollution on the China's agriculture productives. Soil pollution, particularly in growing concern, also for the research and the police market, also the offices in the agriculture department. So the accumulation of the plastic in soil can lead to long-term degradation. So potentially cause the reversible harm to the agriculture productives. So it has proved by the lot of the study in China. So this is a big issue. We all see this issue. So to address this concern, it's necessary for China to adopt a comprehensive approach to plastic management in the agriculture. So including a lot of solutions, including, so for example, investing the research and development of the sustainable alternative and promote the adoption of the best practice of the plastic use and disposal and improve the cycle use. So it also needs the international the cooperation with other countries. So in summary, the plastic plays a significant role in China's agriculture section, but there are growing concerns about the potential long-term impact on soil health and productives. So it's crucial for China to strike and keep the balance between the benefit offered by the agriculture plastic and the need to the mitigation of the negative consequences associated with the plastic pollution. So how
Thank
to
you.
keep.
Thank you very much, Doctor,
yes.
for this very complete
Yes,
answer.
that's all. So we need to keep the balance between the benefit and the negative consequence. That's all. Thanks.
Okay, thank you very much for this very complete answer, highlighting so many interesting points, also related to the effects on soil biota, on animal, wildlife, potential links to human health. Potentially, we could be here all afternoon digging more into the answer you gave. So thank you very much for participating. And Satish, I would like to go back to you, but I'm told your audio problem hasn't been fixed yet. Can we check very quickly? No, right? I'm very sorry. Well, we keep working on that. If you don't mind, I would then pass the floor to Dr. Nitya Manjari Mishra from Odisha University of Agriculture and Technology. Can you hear us?
Yes, I'm here, ma'am.
Hello, welcome. My questions for you, and again, in the interest of time, I would kindly ask you to try and be concise in your answer, is do you think that future agriculture should promote nature-based practices, even if they are possibly less performant than plastics, to ensure diverse food production systems? And also, what is the latest research into the impacts of plastics for soil and the environment, and specifically also related to bio-based and biodegradable plastics? Thank you. The floor is yours.
Thank you. Thank you so much, Galizia. Hi everyone. I am Dr. Nityamanjari Mishra from OUT, Odisha, India. I am an horticulture scientist. Actually, I am presently working on soil fertility, organic farming, and totally based on this to substitute somehow how we can substitute this plastic mulching from our agriculture. So I am technically working on that, how sustainable it is for the farmers, poor farmers, especially in India. So look, if you say that future agriculture should maintain a certain level of nature-based practices, yes, we can do that. But of course, we all know that plastic mulching, plastic in agriculture, like greenhouse agriculture, it highly increasing the productivity of the agriculture produce, which is highly essential to feed the population, a huge population of this world. And simultaneously, what it is doing, that the residue of the plastic mulch and other micro plastic fragments polluting the soils and lowering the organic content of the soil, lowering the water infiltration rate, which gradually, what it is doing, that it is gradually in long term basis, it is gradually degrading the soil properties, and which ultimately, which will be reducing the yield as well. But unfortunately, I will definitely say that we all know that instantly we can say completely no to the plastic in agriculture. We all know that, because it will put direct impact on the food security of the world. Definitely, it will give the direct impact which we can't bear. We can't take that much of risk to say completely no to the plastic in agriculture at the cost of lowering production of the farm produce. Yes, what we can do, so we have we have to move uh, strategically, move ahead step by step. What we can do to reduce the amount of using plastic in agriculture. Okay, so what we can do, we think about how possibly we can substitute the plastic from the agriculture. First, we can think increase the durability of plastic, the using of plastic, durability of the plastic. Next, how you can reuse the usable plastic, how you can reuse that plastic in agriculture, and how we can recycle the plastics that are used in agriculture. After that, then we have to think again where, how, and how much we can substitute the plastic without affecting the production, because we can't afford that reduction in production, because we have also to feed the huge population of this world. And second question, you have told that what are the latest researches? Yes, some researchers we have done how sustainably we can substitute the agricultural plastics to before that, we have to know where we are using the plastics in agriculture. First thing is mulching films. We are using the mulching film, which are directly putting impacts on the soil. So we can shift to what organic mulching, or organic mulching by applying dried leaves, straw, dried grasses, wood chips, etc. And also the cover crops, which can also reduce the crop weed competitions and helps to enrich the soil as well, by adding the organic matters to the soil. This is the best alternative for the mulching. But in India, we are facing the during rainy season, we are facing problem for this organic mulching, because if crop is so much crowded with the cover crops or organic matters, there's sometimes because it is hot and humid climate, we are facing many diseases and pests in this humid tropic and subtropic areas. In this time, what we can do, we can go for use biodegradable films during these periods, and we can also increase the strength of the film, where we can also reuse in next seasons without wasting that. Okay, this is the best alternative. Others are in summer season, in winter season, we can also go for paper covers as well. For small scales, we are using newspaper covers, alternative for the plastics. Okay, next for greenhouse film, how we can substitute that? Yes, greenhouse films are, we can increase the strength of the plastics. Okay, so that it can increase its durability, and also using recyclable plastics. And if cost is not the matter, we can use the durable alternatives such as silica glass for the greenhouse structures, and replacing the plastic nets which are used for shading the in our hot area. We can also replace it with the organic thread nets for shading the areas. Next, what plastic for seed packets, for pesticide containers, highly we are using the plastic. So how we can reduce that? We can reduce the plastic use of small plastic sachets and the plastic containers, replacing with the packaging seed packets with the cloths or paper bags. We can completely remove the plastic from that area, and replacing the pesticides packet into recyclable metal container. Okay, we can we should not use the plastics. Instead of that, we can use the recyclable metal container, which we can again recycle. Next, what plastic pro trays in nursery we are using, which is highly contaminating after that, because we farmers are throwing here and there and it is contaminating. Instead of that, using plastic fruit trays, we can also replace it into biodegradable small mud cups, which is the small mud cups or mud trays or coir trays. We can replace with that. And next, the most important thing is we are highly using the plastics in post-harvest packaging, like from plastic packaging, plastic bag, plastic box, we can shift it to wooden box for packing of fruits and vegetables, and as well as from poly bags for grains, poly bag to jute mat bag, or some organic cloth used bags. We can also use that. So by step, we can completely say no to plastic in agriculture, but step by step, we can avoid the plastic in agriculture, so that we can achieve our goal in future. Thank you so much.
Perfect. Thank you very much, Nitya Manjari. Thank you for sharing so many practical examples on what we can do in agriculture to reduce the use and impacts of plastics. And now back to Satish, who in the meantime has joined from another device. The floor is yours.
Thank you. Can you hear me now? Thank you. So sorry. My apologies. I'm joining with a mobile phone now. I'll try and be brief as I can be. I'm part of an NGO, non-profit body in India, work on environmental issues. And we have also done various amount of work on plastics and microplastics in the recent past. We have also done a study on mulch in India. So I would just like to flag off a couple of issues. It's been a very interesting discussion so far. The growth in the use of plastics is increasing, is a phenomenal rise. It's about 6.4, 6.5 CHER annually globally. In India too, use of plastics in agriculture is growing at a rapid pace, which wasn't there the case about 10 to 15 years back. So we're using much more of plastics. We're also using plastics as mulch. Couple of things on mulch that I just want to flag off. I think there are serious issues about data gaps. We don't have adequate data, especially in developing economies, and I would prefer to say about India. We don't have adequate amount of data as to how much of total land is under, with agricultural land is using plastics as mulch, or what is happening to it is not sure as yet. We do not know. What kind of plastics, what color of plastic? We know by and large there are 4 or 5 colors of plastic which are used for mulch, but there could be some more and for different purposes. Point number 2 that I'd like to make, so data is one thing. Second thing is, what is the environment and human health impact because of use of plastics. Does it impact soil productivity? Does it also release contaminants in the soil? And does that get uptaken in the production of fruits and crop that you consume? And that has got a direct relation to health. Now, this is something where the data is missing. There is very little data on it. Do we have heavy metals? Do we have other kind of contaminants which are there in chemicals, which are used in the production process of plastics? Does it get released because of various environmental conditions when it is in use? And how does it affect the production of food and quality and food safety issues? So that's point number 2. And we need more data, more research on this aspect of it. Point number 3 is an issue which is about disposal of plastics used mulch. This is across the continents. I heard just now from Europe to UK to to other places, and China also, similar kinds of things. We have only 2 or 3 ways of disposing it off, and there are not too many regulatory frameworks as on today in developing countries, and I would say for India, which really govern this. So it is either by burning, incineration, local incineration, or is it by landfilling or putting it at the dump site? All of them, these measures have their own downside impact. So this is serious. We need to frame certain amount of, and it also becomes uneconomical for the farmers to really dispose it off in a manner, especially in developing economies, I can say for sure, to really follow a norm of lifting it from the ground and taking it to a distance place and then handing it over for recycling or something, though recycling also has many downside to it. So let's leave it there. So I'll leave it at this point that it has got downside impacts and we need regulatory framework. We need more data. We need more understanding. And the last thing is we still don't know how much of microplastics is there on the agriculture land. And finally, at the end of the day, all this goes into marine system. It is the sink which absorbs this. The last point I would like to make, does it impact the groundwater? These kind of fragments which are there in the soil, does it also have an impact on groundwater? These are some things that we need to think about. So thank you. We can look for alternatives, technology, and alternates is always welcome. And even plastics can be dealt with some amount of technological intervention. I think Smita also spoke about it, some micronutrients and double coating it and things like that. So those are possibilities, but these are current challenges of plastics in agriculture. Thank you so much. Thank you.
Thank you, Satish, for many interesting points raised, including the need for more data and information on the quantities of plastics in the environment and their impacts on ecosystems. I think this concludes our panel for today. Unfortunately, Divya could not join due to unexpected circumstances, but I would like to express our gratitude to Satish, He, Santilla, and Nitya Manjari for your insightful contribution to today's discussion. It was a pleasure to moderate this panel, and I would like to thank the organizers for inviting me. And I would like to pass the floor to Luca or Valentina for closing remarks. Thank you.
Thank you very much, Julia. It's going to be Luca. And I also join you in thanking all the panelists and the speakers. It emerged from this discussion that there is a lot of questions, a lot of needs for more knowledge, more data, more understanding. Because of this, we set in place this survey that I linked into the chat of this webinar, and I spent the last 3 minutes of this meeting to introduce it. Let me share my screen. Hopefully it works. I hope you can see my presentation.
Yes.
Yeah.
Very good. It's not the first slide though. Yes, this survey is an initiative supported by IKHAPP and also elaborated through the project Papillons. I don't have much time to introduce this project. It's a European Union financed large-scale project dealing with different aspects of knowledge building in the context of agricultural plastic. As part of this, we are interested in collecting a multi-stakeholder perspective on agricultural plastic. Yes, Papillon take care of several of the points that have been discussed today. from the research and innovation point of view, inventories, risk assessment, impacts on agriculture, and so on. The project is on the go and will be concluded in 2025. About the survey, the title of the survey is Plastic in Agriculture, Impact, Life Cycle, and Long-Term Sustainability. We have this objective of collecting multi-stakeholder concerns, knowledge needs, and perspective on the present and future of agricultural plastic. Our main targeted respondents are farmer organization, industry representative, waste managers, NGO representative, officials from national and international authorities and organizations, scientists and experts. So we really want to have a broad scope over the multiple set of stakeholders engaged in this topic, around this topic. And our overarching objective is to create a knowledge gap map to contribute to the formulation of this international code of conduct on agricultural plastic that has been introduced by Richard Thompson early today. Some example of question we will be kindly ask you to reply are this one. To what extent do you agree or disagree with the statement the use of agricultural plastic is necessary for modern farming practices and to feed a 10 billion people world population? What do you reckon are the biggest benefits and environmental challenges posed by the continuous long-term use of agricultural plastics? What do you reckon are the impacts of extensive plastic culture on the quality of life and the value of the landscape? How is the impact on the life and the environment of people living in area where there is extensive use of plastic culture? And what are, in your opinion, the main knowledge gaps related to the management of agricultural plastic? So these are just a few examples. We will ask you also to share your information about your expertise and your role. We are asking this question mostly to stakeholders with professional engagement into the topic along different components of this topic. So the survey, it will be open for the next about 30 days. This is the link, is also available on the chat, and we have already circulated through email to all the participants. Responses will be analyzed and summarized by a group of independent scientists. We are working under the frame of independent research, academic freedom. We do not have any commercial aim in connection with this survey. It's purely for knowledge building. The result of this analysis will be published in an open peer-reviewed scientific journal, Cambridge Prize Plastic. And the result of the survey and the analysis will be transferred to FAO to help them defining this code of conduct on agricultural plastics. So this is for you the chance to make your voice heard. We need to build a robust process to create policies that are workable and that they are effective to make agriculture of this century a sustainable agriculture. And with this, I am pleased to say thanks to everyone. I don't manage to stop sharing now. Okay, just imagine you see me. I just would like to smile back to you and thank you for your attention. We will come back with this series on agricultural plastic later on this year, maybe already with some results from the survey. In the meanwhile, thank you very much again, and I hope you will have a beautiful rest of the day. Thank you so much. Goodbye.